Levels going. Okay. Make sure. Yeah. All right. Cool. We're here. We're live. We're going to do this again. Another week. More Haskell hacking and awesome action. So thanks for tuning in. I'm Agent Ultra. This is the stream where I hack usually in Haskell, and we build stuff. Usually non-trivial stuff, but not like super advanced either. We're learning things together about functional programming and like what it looks like to work on like real projects in Haskell. And so what we're doing these days has been building an Asteroids clone. I've been kind of interested in what Haskell development looks like for game development. Is it possible, good, bad, limitations, trade-offs, that kind of thing? So this is what we have so far. If you're just tuning in and haven't been watching before, welcome. This is what our program looks like so far. Exec asteroids. Right. And we have a little asteroid here. We have a little ship that moves around. We have a little purple hitbox around our asteroid. And poof, we shoot it. Asteroid disappears. Right. We have a full like kind of torusy style play area so that everything wraps around. And we're working on the scoring stuff. So that's what we'll be doing more of this week. So let's go ahead and open up our project. Asteroids, that's the one. Game. Yeah, I'm going to set our variable here. Process type. And that's going to be stack GHCI. Oh, that's not the right, not the right thing. Stack dash GHCI. There we go. Okay. Cool. All right. So, what did we do last time? Where are we in our quest? We just added scoring, as I recall. Or we're working on it. We have a test here. That's probably because there's some edge cases going on in the collision detection. And this test kind of revealed that. We're going to look into that more tonight, I think. So let's get over to our project and we'll get our tests running. Our test runner going with fast and file watch, so it just runs constantly. Okay. So we're getting this here. So let's figure out this test and what's going on and see if we can't change our code to make it work. Okay. There are multiple collisions detected. It should return. When there are multiple collisions detected, it should return the number of detected collisions. In this example, we're expecting that. So we have a couple of we have like three bullets, 3 asteroids, I believe, kind of set up. All right. All right, we kind of have this default bullet. We set up 3 bullets, one at 0.5, 0.5, one at 1.5, 1.5. And, well, they're 10 units across, so they technically overlap. Like their hitbox is like 10 pixels wide. And then we have this list of asteroids. These are really far apart. This one's at 12,012, 0.5. And this one's at 1.5 on the X and 40,404 on the Y. So really far down on our screen. So we're top left 00, 0. And a third asteroid that's at 100, 1,000. So the hitboxes for these asteroids are like 20-ish pixels. And they don't overlap at all. All right, so none of our bullets should be overlapping with any of these asteroids at this point in time. So we're setting our expectation here to be 0.5, the expected bullets list to be 0.5, 0.5, with bullet is dead true. So these ones, true. This one, just to be 2020, not dead, still alive. And these asteroids. Well, we have to have the same positions as the asteroids that we expect here. We just want the deadness to change. So, but I think I was just fiddling around with some values because we found a funky edge case where the count that we were expecting, the number of collisions we were expecting was way off. But if we change this, 4040, 40404, 100 and 1,000. Okay, we should not get any collisions, so this should be false, false, still false, and false, right? Okay, I didn't type in the numbers quite right. Oh, the list positions are different. I see. Probably because like the way our sweep goes through, the way our algorithm works through the list, it's causing things back together in a different order than we're expecting here. That's interesting. Well, in order to fix that, we can either order them the expected ones as in the right order, or we can just like sort them somehow. Because really we only care about this flag being set properly. So let's sort them. Let's try sorting them. Yeah, we're gonna have to sort them somehow because expected B's and expected A's were converting into a deck using this from list stuff. Let's put a little function in front of that. And I think we might need data.list.sort. Okay. Where was I? Sort. Ah, yeah, it's data.list. Okay. Okay, interesting. Hopefully that's Hopefully it's the right order. Oh, we don't need to run the game. Oh, that's not right. Yeah, exactly. No, it's so, GHCI is not running properly, maybe? Because we don't have an ORD instance for asteroids, so it shouldn't know how to sort them. We need sort by. That one, I think, takes a function. There we go. Right, asteroid to ordering. Perfect. And we're going to compare on where's my test output here? Position. Maybe it's just reversed. Because the cons is in a different order. Maybe it's just reversed. We don't need to support. Maybe we can just reverse. And then the only difference, well, not quite. This should be different, yeah, because our expectations 2. Okay, maybe to sort by. Compare on asteroid position. I need data.function for on. Oh, I don't have compare. Oh, maybe it's not CMP. Maybe it's like compare the full word. Oh. Okay, and let's do the same for bullets. Bullet position. Oh, I need sort by on that. Ma by, sort by. Okay. Ah. Okay, the way we need to fix this so that the sort order of our we don't have to check the sort order like what order they're sorting. 'Cause it really doesn't matter. Um, the fact that we're using a deck here that has an order matters, sort of. Actually, that is interesting. I think that might actually matter, so we should pay attention to this. Um, let's look at the game engine for a quick sec. So we update bullets. The bullet physics. Now we'll update the bullet age. Let's see. Yeah, we just take while young game state bullets out of the state. And we check if the bullet tick is less than. Okay. So yeah, so I was worried there the age might matter because I might have been using the deck at one point to kind of um like avoid having to like update the ticks on each bullet and just kind of like kick out the last bullet, you know, kick them off the end of the deck. But I just like dropping the pointer to it and letting the garbage collector collect it. But it looks like we switch that out and update the ticks of the bullet, like how many frames the bullet's been alive for. And the bullets have an age. And we filter them out based on how long they've been, how many frames they've been there for. And where do we update the ticks? Fire a bullet, otherwise just the game state bullets. Bullet timer. Oh, it's just for firing. Control the fire rate. Okay. Set the bullet tick T there. Okay. Oh, okay, yeah. I see what this expression is doing here. So this is, yeah, checking that the current game state ticks minus the tick that we created on. So if game state is at like 5, and we created this on 3, then the difference is like less than the max number of frames we're allowed to be alive for. Yeah, okay. So we don't actually have to update the bullet tick counter or anything like that. We just say it stays alive for a certain number of frames. Right. And then we just filter them out. So yeah, that does mean that the order the, the that we're using a deck here, and the ordering of the deck doesn't really matter here. So when we're writing our test here, we can get away from making that a dependency, I guess. And it also means that we're probably not really taking advantage of the deck structure here if the order really doesn't matter that much. But we can make it incidental in our test, and even if we decide to change that out later, the test should still pass if we use a structure without any order. It just might make iterating over the collection faster, easier, or whatever. So we'll just leave it for now. So yeah, just wanted to verify that the order doesn't actually matter to the game logic or anything like that. It doesn't. So we can write this test and sort this list the same way as the output list, or sort the input lists, the input A's and B's, the same way as we support the output A's and B's. So hopefully we get the same order in this comparison when we compare the two. And do sort by. That's not the right syntax, is it? There. Mm-hmm. Asteroid positions that are doing it funky. All right, well, let's just do it this way. 2, 0, 1, 2. And that one should be 1.5 and 40. Ooh. Okay. Okay. What am I? What am I doing here? I'm trying to get them lined up so that these lists aren't really what matters here. What matters here is this number. I'm expecting... Copy that. Let's make it format a little better just so I can maybe try to figure out what's going on here. Okay, bullets and asteroids. Bang, 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 bang. And this asteroid over here. Bang. Okay. This is the ones, the A's and B's that we're passing in. Or that we're getting back from check asteroid collisions, A's, B's, that we're expecting. So the bullets seem to match up fine. It's the asteroid list that seems to be mixed up. Okay. Because the one we're getting is this one. Let's go. There. And here. Okay, so the first asteroid should be the 1.5. 1.5. 40404. Okay, we expect the second one to be 100, 1000, and the third one to be 12012 and 0.5. Still says it's different. Is that different than last time? let's take our expected list and compare it to our last expected list from the last test run. Bullet stuff is matching up just fine. Okay, so the first asteroid on this test run was 4040. Yep. Okay. That didn't change. Why would it change between runs? And this... Mm-hmm. Oh, no. Song must go. Okay, and yeah, 211202 on not 5, 1000, 1.54040, 40404. Yeah, that should all line up just fine. It's claiming... Okay, so let's compare that to what we have here. So we know that 4040 should be the last one. Let's move that down. And that 12012 should be the first. So let's move that one up. And this should be G to G. Survey says I'm nuts, apparently. So we moved our expected A's around in order to try and line up on this test run. Just double check that our expected is the same as the last time expected. Pretty sure it is. All right, yeah, same, okay. Did our changes to the test expected list have any effect? Did it change, or is it still the same? I'm a little confused right now and I'm kind of tired, so bear with me, bear with me. We will get through this together. Meow, meow, meow. Okay. The last line is 40404, and our first line is 12012. Yeah. Our output literally hasn't changed. Even though we moved... because we're sorting, right? We're sorting them all. Yeah, so they should be the same lists. What could be happening here? That should be 0. Well, they're going to be sorted either way. Actually, yeah, sorry, there must be a difference right here, right? Like, we're sorting them all the same way, going into ext's from lists. This one's getting into check asteroid collisions is coming out this way. But expected A's is getting sorted and coming out this way. Just in the reverse. Because of that cons operation. So if I just reverse this, however dumb that is for now, will that make that go away? No, it'll just make it happen in a different way. Okay, because our algorithm's messing with the order of the asteroids. Awesome. Oh, also I forgot to. I was changing all the numbers. Maybe I'm the dummy here. Green brain. Woo woo. Okay. Okay, it's gonna be fine. It's gonna be okay. We're gonna live. There we go. Yes. Sweet. Okay, so back to my original point here. They're not all colliding right now. The original test was to make sure to test that 2 of them collided. But we found an edge case where if enough of them were overlapping at once, it got a whole bunch. It detected a whole bunch more collisions than we want. Or that we thought we wanted, right? I was hoping that the algorithm would be like a bullet only counts towards the number of collisions once. So even if we had 2 overlapping hitboxes for our asteroids and 2 bullet hitboxes inside those 2 asteroid hitboxes, they're all overlapping, right, in one space. All right, I'm going to try and draw this on screen with my pen so you can see what I mean, but I think that's a pretty accurate description. The idea is that we should only get 2 as the number, the only correct number. 3 is too many. Far is far too much. 4 is far too much. 1 is not enough. 2 is the correct answer. All right, so like our asteroid hitbox, and say we have another asteroid hitbox, and we have a bullet hitbox and like a bullet hitbox, right? If we're iterating through and doing a sweep through these, right? And say we do it whatever order. We get this one first, this bullet first. We check it with the first asteroid we come across. And there's a collision, say it's this one. That should count as one. Uno. Right? And they're both flagged as dead and should not count in any further collision calculations. Then we go to the next bullet, this one here, right? And we check that bullet against all of the asteroids, but we shouldn't check this dead one here. Just this one. Then we we detect a collision, mark them both as, set their flags as appropriately. And then so our final count should only be 2. That's it. That's our goal. And that's kind of like one edge case. And we know kind of just by playing the game that it kind of works, but I think that's kind of what ultimately will demonstrate, at least in that one example, that we probably have implemented collision detection properly, and our game will handle most of the other all the other cases that we care about perfectly fine. So let's try and make that happen. So let's set that up first. Okay, so the bullet setup is fine, right? Let's get our asteroids back. All right, we want the two to be like pretty much overlapping. Remember, their hitboxes are like pretty big compared to the bullets. So these two are going to be definitely overlapping. This one's definitely way out of the ballpark. Nowhere near. All right, that's the original. That's what we had for the original test there. That was failing. And so we want this to be true, this to be true, and we want this number here, the number of detected collisions, to be 2. So now when we look at that difference in the test output, we should see, yeah, the flags aren't set right. All right, well, we're getting 14 here, which is not what we want. Okay, I've messed around with the reverse, and now we're back to square one here. All right, we need bullet is dead true. Okay, so we're getting this odd number here, 14, which is totally wrong. Okay, so let's see if we can fix it to make the flags go away and get this going. Okay. Q. Collisions. Yeah, I'll check asteroid collisions. Okay, so what we're missing here, I think is with is colliding. We shouldn't consider asteroids or bullets that have their is dead flag set. All right, so we should basically short circuit this in that case. We could probably do that with a guard. This would be the otherwise case. And the guard would be asteroid is dead of A equals true. Which will hit this guard. Then we want to turn false. Or if the bullet is dead. Okay, well, it brought our number down. Okay, that's not quite right. What's going on here? This should be 2. Okay. All right, but I got 8. That's not right. Okay, so I think that's... Yeah, the collision check will be false. So we use is colliding as a guard. And we increment collision number every time we detect a collision. We accumulate the asteroids in our recursive argument here. Asteroids. And we recur on the list of asteroids, A of A's. I think this is what makes our order of the asteroids come out a little bit differently than with bullets. However, when we recur on go, we get the bullet that we're working on, asteroids in column, be Oh, this is the bullet we're actually working on, B. We make it the accumulated bullet is dead is true. Okay, so is colliding, the A getting past it is colliding here, is from our input asteroids, not from the accumulated asteroids. So none of those asteroids will have their is dead flag true during the recursion that we're recurring on when we're checking this collision. All right, so go is used here to go over the handle bullet collision for each bullet. All right, so for each bullet, we're going through the list of asteroids, and on that first bullet check that we find, yeah, so we could still, in our test case, we would still find that that bullet would hit those two asteroids, and then those two asteroids would accumulate their is dead flag to false. I'm still not sure how it's getting 8 though, but the next bullet we check. Handle bullet collision gets A's. Gets the updated A's. So it shouldn't be, the second bullet shouldn't be checked against any of the asteroids that have been marked is dead from the last round. And that should be true. Or this branch shouldn't recur any further and should just stop. With the asteroids we've accumulated so far and the ones we haven't processed yet, what would that equation look like? That would probably look like this. We have to turn the bullet where the bullet is dead is true. Right, we'd have to return A, the asteroid we just collided with its flag set to dead. And we'd have to cons that onto the accumulated asteroids we've seen so far. But we have to do something with A's as well, so we'd have to extend this, append those A's. Would that work? Maybe. Might make the order even a little bit weirder, but and I mistyped that. Oh, and we need an int. So we need the call num, the collision numbers are +1. Well, collisions is counting is 6 now. Well, we're still too high. Well, the 2 asteroids are dead with the right flag. That one's alive, which is good. So it's setting the flags right, it's just not counting it properly. Okay, how are we? We're counting here. We're probably adding things up. Okay, so initially, the collision number is 0. In our first pass, we should get this first bullet at 0.5, 0.5 colliding with this asteroid at 0.5, 0.5. And that should trigger the colliding branch. Go here. So collision number should be 0 plus 1. So that'll be call num prime will be that's the value returned from that call to go. So that'll be 1. And so then we have 0 plus 1, which is 1. Then we go to the next bullet. All right, the next bullet should be 1.5, 1.5. That should miss the first asteroid, but the second one is now should detect a collision. We should get to this branch here is colliding. Where our input column collision number will be 1. And so then we return 1 plus 1, which would be 2. Right, so then column here will be 1 plus 2, which would be 3. It must be that the third bullet is actually colliding with these here. That must be what's going on. So we make this bullet go off somewhere way else. And then we should see that drop off to our expected amount. No. Oh, I might have changed the wrong... Did I ever change the wrong bullet? No, the right bullet. 100. Okay. Let's not add to column. Let's just return 1 there. Okay, so we're overcounting there a little bit. Well, 4 is interesting. So the asteroids getting... This one's set to dead. That one's set to dead. The bullets are set. The expected bullets flags are set to dead. That one's not dead, which it should be true. That one should be dead, and that one should be dead. We're still getting 4. I'm wondering maybe if we're still counting each bullet collision with an asteroid twice somehow. And it might be because we're still doing it this formula here, actually. 0. So column prime now is 1 in our first pass. And if we pass that into Go should... Should only... Column prime should only be 0 or 1. I think we're passing in the sum we're counting so far. There we go. That's right. Okay, so now we're just back to the points, the positions being off because of the way we changed the ordering in the equation here while we're accumulating things together and haphazardly. But now we're collecting the right number of collisions that we wanted. So that's good. Okay. See if we can get that sorted. Again. And then we can be done with this. Right, so we just changed the numbers from the expected A's and the original A's. We got to change these back. And this one should be 1.0. 1 and 1. And 1.5. 40404. This one's supposed to be 1.5. This is supposed to be 1.0, 1.0. True. True. No, false. 40404 should be false. And this one should be 0.5, 0.5, 1.5, 1.5, whatever. Your preference is true. Hmm. Okay. We expect it to be not 5, not 5. With true as the first one. Okay. Okay, then we expect to do 1.0, 1.0, false. And finally, 1.5, or sorry, true, and 1, and then the last one. Oh my god, so far, so much for making the order not matter. What am I doing? Hell. Let's get rid of the sort by on it. Maybe that was a mistake. Yes, we got it right. We just can't match them together. You're not 5 in the middle. There we go. Okay. It's a bit sensitive, but it'll be fine. It'll be okay. Okay, so we used a pretty uh, chaotic sort of formation for our collision detection to make sure that it works exactly the way we want, even in that edge case where everything's overlapping, and now it does. So hopefully the theory goes, it'll work in all the other cases too. It's not a proof that it will, but hopefully it's good enough. So when we have lots of overlapping asteroid and bullet bounding boxes, we only want to count the first pair of colliding boxes, colliding bullet and asteroid boxes once. I don't know if that makes sense. We only want to count the asteroid as collided with the first bullet encountered and should not be counted again. Hopefully that makes sense. The code's a bit tricky to read, I'll admit. Okay, so now that collision is happening, that collision detection is happening, that's good. So that means that count that we use is used in scoring as well. So your bullet, when it destroys an asteroid, that's increments your score by 1, right? It doesn't count if it is detected to be overlapping with 2 asteroid hitboxes. We don't count that bullet towards your score twice, right? Just once. That's why we want that. So, I think we can rebase this what we've got so far, squash those together, reword this. We'll just call it add scoring when an asteroid is destroyed. When a bullet collides with an asteroid, destroy the asteroid and bullet, increase the score by 1. An asteroid is only counted once per frame, even if it's there are multiple colliding bullets, or the bullet is detected as colliding with more than one asteroid. Actually, I like the wording of the first time we did it. Okay, that's good. Okay, let's push that up. That's good. It's good. Okay, and when we run our game again, it should be just like it was before. All right, boom, boom, flying around. Phew. Okay. Only now we can display... We should probably come up with a score display, I guess. It's probably what we should do. Is there Is there an easy way for us to display just a little bit of text in our game with SDL without having to pull in a whole bunch of another dependency, basically? So I have to pull in libsdlttf. SDL2 display text. Yeah. So I'm going to avoid TTF for now. I mean, it's going to be unavoidable when we do menus and stuff. So probably going to need it at some point. Okay, Haskell, SDL2, TTF. Okay, looks like it's in a separate package. I don't know what the raw font. Probably don't need the raw font. Let's see SDL font. We initialize it. And it looks like it uses or builds on the SDL2 library we are using. At least it links to Surface from that library, so they should work together just fine. Okay. Let's see if I got the library. I'm going to need that. Okay, and then we're going to add this package, SDL2-TTF, to our deps. It may not be in our thing. Okay, just have to build it properly. Oh, okay. Okay, got the library loaded up. Okay, cool. Now what do we do? Well, we'll have to import it. Import SDL.font. Qualified SDL.font as font. And our initialization. Run. There we are. Okay, so we have to font.initialize this library. It just returns... Doesn't return anything. I think we should just be able to use it like this. We'll start on our file builder. File launch. Yeah, compiles at least. That's a start. If call initialize cleans up any resources still in use. So call font.quit. Okay. So have to use the following functions to load TTF and font file formats. Load. Given a path to a font file, loads it for use as a font at a certain point size. Okay, so we're going to need an open source font for our game. OpenGameArt.org, a collection of fonts for use in video games. Looking for general UI related stuff, user interface collection, pointers, cursors, crosshairs, blah, blah, blah. Hopefully the licensing on these is okay. Let's see, null terminal font. That's a bitmap font. Okay. We're kind of looking for TTF. Bitmap fonts are fine for certain games. Definitely can work well. Not quite what we're looking for. Let's qualify those TTF. I don't know about the licensing on any of these. Is like, hopefully they're okay. By the way, chat, if you've got any ideas on where to find cool but free and open source fonts for games, let me know. Creative Block. 10 remarkably retro-free pixel fonts. Yeah, that looks kind of like a thing. Dafont.com. Looks like it's a TTF format. Licensing information. The fonts presented on this website are their author's property and are either freeware, shareware, demo versions, or public domain. The license mentioned above the download button is just an indication. Look at the README files in the archives. Or check the author's website. Okay, so it's kind of like, do your own research. We're just hosting them. There's a button, 100% free. That's just the FAQ. We'll download it and see if there's this README file here that says anything about this. Fontsforflash.com. Sounds like it's a purchased font. That's dubious. It's free for personal use. You'll need to buy a license if you want to use it commercially. I don't know if we count as commercial. Open source fonts. Okay, let's see if we can find something useful here. SIL open font license. Okay. PostScript. All right. Let's see. Info. Open font license. Okay. Cool. It's an open type font file. I don't know if SDL TTF handles that. Or SDL TTF even. It's hard to say. This is the most annoying part of trying to get this stuff going. Is finding assets when you just need PostScript. TTF, true type. TTF open source font. Eesh. What's the license on this one? Source Fonts Pro, sure. Under the open font license, you can use them in your products and projects, print or digital, commercial or otherwise, as in the blah, blah, blah. Okay. Cool. Do it. Do it. Okay. I'll put it here. Okay, and we'll start a little directory. Assets. Fonts. Okay. From mount. C. And noticia text dash bold.ttf to here. There. Okay. Cool. Okay, we got a font. Super. Super duper duper. Let's see if we can load it now. Font.load, I think the function was, right? Yeah. File path, point size. Okay. Load. Now, this is going to have to be, ultimately, we're going to have to figure out this file path to, like, relative to our, like, where our binary is and where we expect all the data files paths to be and stuff like that. I think we can do assets / fonts, noticia, text, dash bold.ttf, point size. Hopefully that's just an alias to a number, but what do we need? Yeah, it is. Based on 72 dpi. Let's do 28. Seems okay. And that returns a font, so we'll need to hold on to that. F noticia. Okay, we don't use it anywhere yet, so rendering. Okay. Okay, renders text quick and dirty. Let's do that. Sounds great. Let's just do font.solid. What do we need? The font. Noticia. We need color and some text. Colors of V4 of word 8. We'll do it in white. And text. Hello. Returns a surface. Okay. So I guess if we want to render that, we have to render that onto our renderer with a regular SDL renderer. Do we have a function for this in SDL? Surface. Copy the Windows surface to the screen. No. Surface blit, not really. Surface fill rect, no. Convert surface. No, no, no. How do I render a surface with a renderer? Create a texture from a surface. Hmm. I don't know. SDL2, renderer, text. Well, that was the question we were looking at before. I know the old SDL used to use surfaces, and SDL, I guess that's what SDLTTF is using, but I guess I was kind of assuming that you'd be able to do this with renderers. So that creates an SDL surface, convert it into a texture, create a rect, render copy. Okay, okay, okay. Right, right, yes. Yes, coming back now. It's gonna load it as a texture, right? And so do we have renderer copy? Yes. Yes, we do. Which takes a texture, a rect, a pair of rects, and then does an int. Okay. So we had the convert to texture. Oh, we got a surface from solid. Create texture from surface. Okay, so then we got to do that. Hello tech. And that'll be create texture from just create texture from surface. We already have that. Okay. Surface, and we give it the renderer. We give it the surface, which is hello surface. Okay, and then we can SDL dot copy. renderer, hello tech. And then we need 2C ints. Render copy. Pointer rect. Well, they don't make it easy, do they? That's okay. We have to do something to create a pointer. And we know how to make rects, I think. STL.p is a point. No, not a pointer, but rectangle. STL.rectangle. We'll, I don't know, 10, 10. Render copy is not in scope. Where do I get render copy from here? STL.raw.video. Okay. Maybe the reason why that's annoying to use is because we don't actually want to use it. Maybe it is. Maybe it's the only way to use it. Okay, STL.raw.video. Okay. Video.render copy. Should be good now. Ish. So our whole. That one's fine. That's not in scope. That's cool. We can fix that. Hello, tech. Okay. This hole. What's this one? Create texture from surface. Returns an M texture. We want, yeah, it's a texture. Okay, it says expected an STL.raw.types.texture. I got an actual STL.texture. How do I get it to the raw types.texture? Okay, this might be the higher level API we want to use. Takes a renderer, a texture, a maybe rectangle scient, maybe rectangle scient. Okay. So this hole should become just STL.p, right? Okay, cool, cool. Everyone's happy. We're compiling. Okay, let's see what this looks like. Okay. We're in the wrong folder. So that's like all path stuff there that we're going to have to handle properly. Maybe we need to set the other rectangle. Yeah, I still don't see the text anywhere. Ba, 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 ba. Okay, let's make sure we understand the rects used here in this API for copy. So the source rectangle to copy or nothing for the whole texture. Okay, so the first one will do nothing to get the whole texture. That's exactly what we want. This one to here. And the destination rectangle to copy to or nothing for the whole rendering target. The texture will be stretched to fill the given rectangle. Okay, so we kind of want this one to be set, I guess. Hey, Swarm Collective, how's it going? Welcome, welcome. Wow, cool. I don't think I've ever... Well, that's not true. It's a very rare occasion that someone just downloads code to read it, so thank you. I hope it's going well. I've been well. Thank you for asking. How have you been? So that should be good. Let's check this out. Okay, we're not getting anything yet. Let's see. It could be because we're rendering over with the clear screen. So let's move this down. So I guess we're going to have to put our font into the game state. Don't follow along with this at home. Cool. Yeah, add some features. Go nuts. Share those, man, and I'll show them on the stream for sure. That'd be great. Love to try it out. See what you come up with. I think that would be very cool. So we want font. This is super hacky right now, so bear with me here. I'm just trying to do the minimal amount to get that font down into our rendering loop. We actually do rendering. so that we can render it over everything else. Okay, so we have it in the state. Game state not initialized. Yeah, that's right. So we need a value here for game state font to equal. So not only will it take a renderer, it'll also take our asset as input. SD or font.font. And we call it a game here. So we're going to have to move this down here. That F noticia is here. Okay. I think we can just pull that up. And go down to render. And we'll put our little hello surface here. This will be game state font. This will be game state renderer. Along with that one too. There we go. Some text. Squish text, but text. That's because we're not dynamically figuring out the size of the text based on the length of the string and like the size of our font. This can get pretty complicated depending on the font you choose, of course. Mono-sized fonts are going to be a lot easier to size the textures properly. Well, that's a start. So we should be able to render the score, which would be good. Right? Let's see, we're out of time. Oh, I'm so sorry. So yeah, maybe next week we will do font rendering and UI rendering stuff for the game. So we're getting close. There's only a couple of play things we have to do left. We have to do ship collisions. And we have to do the special handling of like what happens when an asteroid gets blown up. So for like little asteroids, we have to dispatch to like an explosion animation, and for the big asteroids, we have to explode and spawn 4 more small asteroids. And then we have to respawn some asteroids. So there's like 3 or 4 things left on our to-do list, and then UI work, and then we're good. We'll have a full game. So check out for that. Keep up. I do these streams once a week on Tuesday evenings at about 10 after 8 in the evenings in the Eastern time zone. So if you're around and this is your first time tuning in, that's my sketch. You can, of course, just click the subscribe or follow button here, and then you'll get updates when I go live. And if you're watching on the YouTubes, you know what to do there, of course. And you'll get all the updates as we go along and develop the project. The code for tonight's project, I'm going to push up our hacky stuff that we've got so far for font rendering. Add a hello world texture and progress UI stuff. And this code all lives on GitHub. Okay, you can find it on github.com. All right, agent ultra. Nah, that was the wrong address. Agent ultra, that's me. On most of the socials, and Asteroids is the project. If I could type my username properly, that would be great. There we go. Finally. Woo. I'm Agent Ultra. This is Asteroids. This is where you can get the code. You can check it out like Swarm Collective and be awesome. And yeah, or not. It's all good. If you just want to come in for the sweet tunes and hang out, that's cool too. I'd like to have you. So there's that. You can also go to the link above to find a cool Discord server with a bunch of channels, including the channel for this stream. If you want to follow along with updates as we go in between episodes and streams and whatever. And yeah, thanks for tuning in. See you next week. May all your monas be free and may your types always check. See ya.